We're here at the AMA's International Aero Modeling site. I'm with Marc Gellart. We'd like to give you some overview of some of the simple and the more exotic aircraft in sailplanes and soaring today. Marc, tell us a little bit about the range of aircraft that you can get into with soaring.
Tom, we've got a number of classes, the smallest being hand-launched. These are 60-inch wingspan airplanes, and guys actually physically throw them. Then we move up to 2-meter, which can be a number of construction methods. Then we work up into unlimited, which is what this phaser is right here. And then we have RES, which is rudder, elevator, spoiler, 3-channel class. And then we also fly a nostalgia class, which are aircraft that were all designed or published prior to 1980.
Okay, so that would be some of the older type aircraft, old-timer type comparative with the powered aircraft.
Correct.
Give us a little bit of overview, Marc, of your background. I know you've been flying in soaring and sailplanes for quite a while. Give us a little bit of an idea of what you've done and some of your accomplishments.
I've been flying sailplanes since 1975. I'm the founder of the Ohio Valley Soaring Series. I was the 2004 National Soaring Champion in winch launched cross country. And I am the 2005 NATS Event Director.
Okay, great. So you've got a long background in soaring. Give us a little bit of an overview of the type of flight regimes that you go in from launch on out.
Well, Tom, we have, basically you have 5 flight regimes: launch, cruise, thermaling, reflex, and landing. And each one needs different trims on the trailing edge. You can have preset positions and also positions that are active relative to other surfaces on the airplane. Let's say the elevator relative to the trailing edge of the wing and thermaling. A fixed position like in reflex that we actually raise the trailing edge just a touch, those kind of things. And what it does is it allows us to utilize an airfoil over a broader range of airspeeds and conditions that we couldn't do when we didn't have the trailing edge changeability or camber changing as we use now.
And that type of function you pick up with the programmability in the radio or the transmitter itself.
That is correct. If we didn't have, to a certain degree, if we didn't have computer radios, we wouldn't be where we are. There have been guys that have gotten it done with the older analog type systems, but when computer radios came to the forefront, this airplane came to life.
Give us take us to the next step. We've gone past launch and now you're in your cruise or search mode, correct? What are you looking for when you get into that mode from the function of the aircraft and with the radio?
When we've come off the line and we've gone through our zoom and we've leveled off, the trailing edge will be clean, or in this case with this airplane, I'll actually have the trailing edge just down a touch, maybe a 32nd of an inch. And we start a normal cruise pattern that we're searching out for air. And hopefully, most people, when you step up to the winch, you've already identified areas that you think will be productive, or you've got a guy that's spotting that, say, go there, you'll see something happening, a hawk or a buzzard. So you take off and you go from your launch, do your cruise, and get to your thermaling site. You see some indications in the aircraft that it either speeds up, the tail rises up a bit, you get a wing kick. Any of these type things will tell you that you're getting in the lift area. You go ahead and we drop the trailing edge a little more, we'll slow down, and then we'll start doing a circle within the area and try to center on the strongest piece of lift in the area.
Okay. What would be a typical flight time? How long are you normally up on a timed event?
At the Nationals this summer, we'll probably be flying, most of our flights will be between 6 and 12 minutes.
Okay.
Some contests will go as much as 20.
Okay, so it's a reasonable length of time. Now, I know that when you get into the most sophisticated aircraft, you're actually running instruments in the aircraft like varios and so on?
That is correct.
Just a little bit of overview of what you're looking for there.
There's 2 different areas that we fly with this. There's actually data loggers that can actually keep specific altitude, time frame information that you can download to a laptop. And then there are the varios, which have become very small and very accurate, that not only are giving you altitude, but they give you rate of climb, and they also give you feedback as to battery condition.
And so you know exactly where you're at. On the subject of batteries, do most of the very active sailplane flyers today use lithium polymer, or is there a preferred type of battery?
Most guys, I don't know what it would fall, but it's mostly nickel metal.
Nickel metals.
And just the normal old NiCads, one or the other.
Okay. We talked about the launch. We also talked about the cruise and search. Now, once you've hit a lift and it's starting to go away, you then go into reflex mode. Give us a little description of that as far as what that means and what you're looking for in performance of the aircraft.
Well, in a typical flight, especially with some of the longer ones, we may need to cover some ground to get to that next piece of lift. And what we can do is when we leave that thermal or that area that's topped off, we know we've got to cover some ground. So instead of adding more camber to the wing, we actually will take it away by raising the trailing edge,
Okay.
getting it cleaner, and then that will give us a better dash speed and with less drag. So we can cover ground very efficiently. We get over to where we want to be, then we're going to slow the plane up, take it out of reflex, and hopefully we're at a spot where we've had picked out that we wanted to go to get lift again.
Any idea of what a typical speed is when you're in your cleaned up mode and you're going into reflex for a high performance aircraft like this Phaser?
Well, I know good and well they'll get to 100 miles an hour very easily,
so
especially if you really get a head of steam coming downhill.
Okay. That takes us through the first three. At that point, you're basically going into landing mode. Give us a little description there of what you're looking for and what you do.
That's, okay, let's say we're at a 10-minute flight and we're at 8 minutes. And we've topped off. What we'll do is we'll break out of the thermal just like any aircraft coming down off of a flight or a mission. We'll come down. We'll try to be at a target time at a target point, which for me, I normally try to be even with myself at 30 seconds so that it's approximately 10 seconds of downwind, 10 seconds of base, 10 seconds back in on final into approach. Depending on the contest and how busy the landing circles are, that doesn't always work, but it's kind of my time frame I use in my mind. Normally on base leg, especially with the cleaner planes, and even though we have flaps, I'm trying to get my energy situation where I want it on the downwind. You don't want to come around clean and hot and expect them just to shut down on final, because normally, even though we can slow them down a lot, they will still carry a lot of energy. They're very efficient aircraft. Okay, we're starting a search pattern here. I'm about a 45-degree angle to the wind so that I can see the difference between one side of the airplane and not. Like right there, it looks like we've got air right here to the left of the airplane. Oh yeah, air big. What you're looking for is a change in airspeed or the tail to rise, or it's a speed up, just to change from what you've been going in. See, like right there, she picked up. And it's subtle sometimes, but there's lots of little bubbles out here on this field right now. Really climbing right there. Nice stuff. Put a wrap in. We'll do a little push and see if it's better upwind, and it looks like it is. And we're climbing the whole way. So I just barely got into the lift. Oh, big nice patch of air right there.
Now, what mode are you on here, Mark, on the transmitter?
I am thermaling and got the trailing edge dropped as much as it'll go, plus elevator to flap mix, just to give it even a little more when I really want to pull back on it.
Now, the typical high-end aircraft like these, Mark, are in the composite type construction, correct?
That is correct. I mean, nowadays there's bagged over foam, but pretty much everybody has gone away from sheeting over foam.
So this aircraft is which of the construction
This is a fully molded airplane. It's just like a real sailplane. Uses carbon, Kevlar, fiberglass, sandwich, a fully stressed skin, and hollow core wing.
And all up weight on this with gear, etc., is about 75 ounces.
That's correct. Now, okay, I'm topped off here what I think is there, and I'm going to just go ahead and start a cruise upwind. I've got the trailing edge even. I'm not in reflex. But if I go there and then do that, then I've got reflex in it.
And the reflex did what again on our control surfaces?
It brought up the entire trailing edge.
Of the wing?
Of the wing.
Okay.
That is correct.
Now, I know a lot of guys in the other segments of the sport fly digital servos, and on the high-performance aircraft and sailplanes and soaring, you're running the same, correct?
You betcha. This airplane has 5 368s all in the wing and the rudder, and the stab is operated by a 3421 JRDS.
Do most of the guys run the PCM receivers, or are they mixing between PCM and FM?
It's a little both. This has got a JR 770 in it, and it's the first time I've ever used PCM, which has given me tremendous range on these composite planes, because sometimes these things can be a little fussy with the carbon Kevlar hybrid fabrics, and this has worked very well on this airplane.
Of course, the other advantage when you get into the really high-performance sailplanes like this with the digital servos is it holds so tight at center and can to allow you to not have any type of a structural or a gear failure in your servos from flapping or letting it get off center.
That is correct. These servos are so tight and so powerful and hold their center so well. You know, used to you would come in off or go to start another flight and you'd have to recenter everything. These you may not have to center in days.
Now at this point you're going to go ahead and set up here for landing, correct?
Correct, that's correct.
Ah.
Close enough.
That's a really good overview of sailplanes and soaring, Mark. Let's go ahead and tear the aircraft apart, look at the servos, the mechanical setup, and give everybody an idea of what you put together on an airplane like this.
Okay.
Well, Mark, we've got the airplane apart now. Let's show the folks a little bit of the detail involved with the setup of the aircraft, both the servos and the electronic components here, like your multi-plug.
Okay. Most of all of our airplanes have some sort of access panel per surface, per servo. What we've got here is a JR 368 servo and a mount that we get from Craig Greening, who is in California. It's a really super mount. You can get your servo in and out if you need to do some adjusting or some work. You'll notice the wirings here going on out to our plug for our aileron. All of this ties in directly from all the wing into this DB9 plug, and actually this wiring harness as a single set came from a gentleman named Tom Hoops. And when we were showing the fuselage, we took it apart and had the view there. You notice there was a little carbon fiber 90-degree plate in there that held the other side of the DB9 plug. But basically, you've got this all comes assembled. You've got your wiring harness laid out, and it goes to your individual servos on out. And you do have to glue in your one servo plug out here at the aileron for the aileron servo to be plugged in at the end of the center panel. Like I said, these mounts make life very easy for being able to get things in and out. There's lots of pros and cons. Everybody's got a little bit of their different way of doing it. So
this plug assembly and the wiring harness is a complete set?
Yes, it is.
You can buy that as an assembly and then put it in?
You can get that from Tom Hoops. You betcha.
And he was based where?
Out of Salt Lake City, Utah.
Salt Lake, okay. Well, good. That gives us a good overview of how high-performance sailplanes' wing and servos are set up. Thank you.
Yes, sir.
Let's switch gears just for a minute and talk a little bit to the brand new person that may be already in modeling but hasn't flown sailplanes at all. Give us just a few pointers or tips, Mark, for a new person starting out. And I realize they're not going to be with this type of high-tech bird, but how to launch, high start versus winch, just some basics.
As I've told you before, I don't even own a winch. I use a high start. But for the guy that's interested in wanting to go out and fly this stuff, there's a number of different airplanes, both kits and ARFs, that allows a gentleman to fly, when we talked about RES type airplanes, that it's rudder, elevator, spoiler, or just rudder, elevator, that if a guy wanted to go out and try thermaling, and he's a competent left, right, up, down kind of a stick, he could go out and get an airplane put together in a weekend and be flying. And most of those airplanes you're buying to do that, a high start will work great.
Okay.
Literally you can go down to Ace Hardware and buy surgical tubing now, and literally, buy yourself some line, put a little streamer on so you know where the end is, and 50 foot of surgical tubing, of light surgical tubing on a 2-meter size airplane, some line, and a little flag, and you're ready to go launch.
So for those guys that don't know that literally are beginners or neophytes, a high start is a surgical rubber device that basically is a large rubber band that pulls the aircraft up.
That's exactly right.
And a winch is a mechanical device that has an electric motor, a pulley, and another pulley out at the other end that pulls it around and launches the aircraft up off the line.
I mean, the winch is and depending on what you're doing, there's a number of different ways of doing it, but basically it's a long shaft forward starter motor on a drum.
And for those guys that are scale buffs among us, there actually are tug or tow planes that are used to pull up the scale birds and go full
Aero
scale.
tow has just gone nuts. Aero tow has come just miles and miles, and we have these beautiful scale ships now that 5, 6, 7 meter airplanes that weigh 20, 30 pounds that fly wonderfully.
Yeah, they fly very nicely. Well, that's really all we'd like to cover today. The aero modeling side of sailplanes and soaring is probably one of the most challenging and exciting in the different specialty groups that we have in the sport. So we thank you, Mark, for the information that you've given us today, and we hope that we'll have some folks that are flying other types of aircraft that come over to soaring.
We hope so too.
Thank you.
Thank you.